Hello everyone and welcome back to the channel. In system design, one of the first and most crucial questions you will face is how do you handle more users? How do you scale your system as demand grows? The answer lies in scaling strategies. While there are many techniques, they boil down to two fundamental approaches: vertical scaling and horizontal scaling. Understanding the difference, their trade offs, and when to apply each is absolutely essential for any system design interview. Today, we are diving deep into these core concepts. Okay, so let's start first by what is a scaling. Let's say that we have our client that sends requests to our server or our app. Okay, let's say that we have another client that sends requests to our server. Let's say that we have another one that sends requests to our server. And let's assume that our server can only handle one client, but we have three clients trying to send requests to our server. So we need to scale. We might add more resources, we might add more servers, so our server can handle all these clients. This process is called scaling. So a quick definition in system design: scaling refers to it's the ability of a system to increase its capacity to handle a growing amount of work. This could mean more concurrent users, more data processing, higher transaction volumes, or increased storage needs. When a system scales well, it can continue to provide constant performance and availability even as demand increases. Okay. So let's talk about vertical scaling first. So the concept of this strategy involves increasing the capacity of a single existing server by adding more resources to it. Think of it like upgrading your personal computer. You add, for example, more RAM, more CPU, faster storage, or enhanced network bandwidth. You're making like one machine more powerful. So when we have a client here, and this client sends a request to our server, okay, and our server right now only can handle one client. So when we have another client try to send requests to our server, but our server only can handle one client, so we need to scale. So we will use vertical scaling or scaling up. We basically add more resources. We can add more RAM, more CPU, so our server can handle this client. Also, our server can handle, for example, more clients when we scale right. So how it works, it typically involves replacing existing hardware with higher capacity components, or in cloud environments, you resize a virtual machine instance to a larger one. The pros of this one: it's simple, like it's generally much simpler to implement and manage as you are dealing with just one machine. It's easier in management, like less complexity in terms of data consistency or inter-server communication. It has lower latency, so no network latency between different components of your application if they reside on the same server. The cons of this strategy. First, we have a hardware limits because there is a physical ceiling to how much you can upgrade a single machine. Eventually, you will hit the maximum available CPU, RAM, or disk capacity. Also, we have a single point of failure. Since we still have one server, if that one powerful server fails, your entire application or critical component goes down unless you have a separate failover mechanism. Also, downtime. Upgrading hardware often requires scheduling downtime for the system. And lastly, the cost, because high-end, very powerful single machines become really expensive. Okay, so what is horizontal scaling? So this strategy involves adding more servers or instances to your system and distributing the load across them. And instead of building one giant factory, you build multiple smaller identical factories and split the work among them. So how this will work in theory? So let's say that we have two clients and we have one server here, and they try to send requests to our server, but our server can only handle one request. So we need to scale. So instead of adding more resources, we will add more machines. So we'll add S2. So right now, client 1 can send to S1 and client 2 can send to S2, and when we need more clients, we add more servers and so on, so we can just scale as much as we want. So how it works, you deploy multiple copies of your application or service across different machines, and we in between, I guess I need to talk about that. In between, we have something we call a load balancer, which basically will distribute all the incoming requests that are coming from the clients across the servers, because the clients doesn't know the locations of all the servers. So the load balancer the load balancer then here will distribute the incoming request evenly among these instances. For data stores, this often involves like sharding and stuff like that. For distributed servers, you just distribute the load and that's it. The pros of this one, you can add virtual unlimited servers to handle increasing demand, theoretically providing unlimited capacity. Also, you have high availability and fault tolerance, because if one server fails, if you have this one fails, for example, server 2 can take in place. And this eliminates a single point of failure for your compute layer and significantly improves the uptime. Also, you have no downtime for scaling. You can add more. You can add or remove servers from your pool without interrupting the service at all. Also, the cost-effective. You can often use cheaper hardware systems, which will not be that expensive if we use like vertical scaling. The cons of this system is complex. This is the first thing, because this is the biggest drawback, I would say. Managing multiple servers, implementing load balancing, ensuring data consistency across distributed data stores, and handling inter-server communication add significant architectural and operational complexity. Also, data consistency challenges. Maintaining data consistency across multiple distributed databases is really difficult. Also, we have network latency. Communication between different servers in the cluster introduces network latency, which can impact performance. Also, as a problem with debugging, like troubleshooting issues in distributed system is inherently more challenging. So, when to use which? So, let's talk about some rule of thumb. So, start with vertical scaling all the time for initial growth and simplicity, as long as it meets your performance and availability needs. You can, after that, transition to horizontal scaling when you hit the limit of a single machine, or when high availability, massive scalability, and fault tolerance become paramount. Also, you can use a hybrid approach, like in most real-world large-scale systems. You will see hybrid approach. For example, your application servers, which are often stateless, are great candidate for horizontal scaling behind a load balancer. For example, your primary database, especially for writes, might be a vertical scaled initial to maintain simpler data consistency, but then computed with horizontal scaled read replicas to handle read-heavy workloads. Eventually, for massive writes scale, you might consider database sharding, things like that. Okay, how to discuss this in systems interview? So I would say in a systems interview, architectural both strategies clearly, like don't just pick one. Always discuss the trade-offs involved, simplicity versus scalability, cost versus resilience. Justify your choice for specific components in the system you are designing. For instance, I would scale the web servers horizontally for infinite capacity, but for primary database, I would initially scale vertically for consistency, adding horizontal read replicas to handle the read load. This demonstrates a mature and balanced approach to a system design. So yeah, that's it for this video, and see you in the future.